So let's start with the simplest of the acids and the simplest of the bases. So let's react together. Formic acid or methanoic acid, and that becomes important as well. So let's take this acid and react with the simplest of the alcohols, which is methanol or methyl alcohol, or wood alcohol if you wish, but we're going to avoid that name. And again, this is going to take the and we got to have catalyst in there, the hydrogen from the sulfuric acid. And it's going to remove this H and this OH to form water. And that means that this CH3 here is going to come over here and replace the H, and that H is going to come over here and replace the CH3. That's your double displacement. And so we get HCOO, and then this CH3 goes on the end, plus water. And we're not going to deal with phases. We're not going to worry about phases. We're just going to get the basic structure here. Now we're going to name these. And again, there's two naming systems we have to be aware of. And that, of course, is the IUPAC or the structural naming system, or and the common naming system for the other. Or the systematic name, not structural, the systematic name and the common name. So let's deal with the IUPAC, the systematic name. And before we do that, let's go through and write down the name of the acid according to IUPAC. And that, of course, is methanoic acid. And this right here is methanol. Okay? Now, and we're not going to name water. I think we all know how to deal with that. So this is how this works. Because the methanol loses the OH and the methyl group, and that is now a methyl group once it's lost the OH, attach itself over here. That's the positive part of the salt that we've created. So that name goes first. Methyl. And then we lose the hydrogen here, so it's no longer an acid, it's now technically a base. When you lose a hydrogen, the result is the conjugate base, which we're going to deal a lot with in the next chapter. But when that happens then, we drop the IC acid. I don't know why I have an E on the end, but I guess I like the letter E today. It's only natural. That's a calculus joke. All right, so, but all the other times when we dealt with acid bases, when we lost the hydrogen in an acid that ended in ic acid, the ion, the negative ion from which it came, has a suffix of 8. So that becomes methanoate. And this is IUPAC, so this is all one word. Oops, there's my met. I'm going with the letter H today, I guess. Methanoate. Now notice the O did not come off. Make sure it stays on there. But that is methyl methanoate. Now, common name. Common name for this was formic acid. Common name for this is methyl alcohol. Okay, so same thing. This just becomes a methyl group like we did up there, but this right here ends with 8. So the common name for this is methyl. And it's 2 words. Remember, common name has multiple words, where it's all one word for the IUPAC. And this is methyl formate. See, none of those parentheses and numbers flying all over the place and oxys from out of nowhere. Not out of nowhere, because there is a method to the madness, but this is much simpler than finding the name for, to me, than finding the name for an S on ether. All right, let's do another one. Let's take this one. Thinking don't write it down, don't write down the name, don't write it down, and I wrote the name down. So it's this. Oh, that's supposed to be carboxylic acid, sorry. Doesn't have to be, but I prefer to put the acid first, since that's it's going to be the acid. When I do acid-base reaction, I like to put the acid first and then the base. Doesn't have to be done that way. You can do it differently, whatever works for you. And this. Now I'm just getting nasty. And again, we're going to put an H positive right here. And so what we're going to do is we're going to go ahead and write the structures for the product. Well, we know one of the products is water, so I'll just put H2O right here, and now the last time we talked about it in this instance. Now, here's where we got to be careful. First of all, we know that the H here is going to be removed. We'll try the blue. It works. And the base here, the OH, is right here. I knew that was going to work. I knew I was pushing my luck. Oh, okay. So the H here is going to come off. Oh, not yet. Sorry. I was getting so upset about the OH, or the blue not working. Let's try that again. There we go. The OH is going to come off there. My bad. Okay, so it's the H on the left and the OH on the right. And so those two are going to come off and form water. So, in drawing the structure, CH3, CH2, COO, this oxygen is going to bond to this compound where the OH is. Now the OH is not on the end, it's in that second carbon. So this CH group belongs right there. Now, that is also bonded to two methyl groups, if you will, two carbons. So you can draw it a number of ways, but I'm going to draw it this way. It's CH3 here and CH3 here. Okay? So now we need to come up with a name for this compound. Two names: systematic and common. So let's do the systematic first. Let's give me the name, the systematic name for this acid. 3-carbon acid is propanoic acid. Yeah, let's use another color to emphasize the difference going on there. Of course, I'll write out half the column. Okay, now again, I'll use the green for this. This is propanoic acid. Okay? I don't learn how to. I had a 4th grade teacher who told me I'd never become a teacher because I didn't know how to write properly. Alright. And then this over here. Well, this is a propanol, but the OH is on the second carbon, so this is 2-propanol. Yeah, now we're dealing with numbers. And it comes back to haunt us now, but it's not too bad. It's not like the other one. It's just crazy. That numbers flying all over the place. This is going to make sense, I hope, for you. So, when we drop the OH here, this becomes a propyl group, but it's not just a propyl group, it is now a 2-propyl group. And that is now our replacement for the H right there. That is called 2-propyl. And then the base name, because this acid has lost its hydrogen, we drop the IC acid and we put 8. So that becomes propanoate. And it's one word because it's IUPAC, propanoate. So there's the name of your ester in terms of IUPAC, the systematic name. Now let's do the same thing with the common name. So the common name for this, if you recall, 3-carbon acid common name is propionic acid. And the common name for this, well, what is the common name for a 3-carbon alcohol with the OH on the second carbon? That is isopropyl alcohol. So we drop the alcohol part of this. That is your acid part. So the common name is going to start with that. Let's use the red for this. Alright, and this gives us then, we'll start off with isopropyl. You don't have to capitalize it because these are not, you don't run up to somebody and say, hello, Mr. Isopropyl, and then give the respect for the capital name. No, you don't have to, but this is just a thing I like to do, isopropyl. And then this loses its hydrogen, which makes it a base. In order to make that a base, you drop the IC acid and put 8 right there. So that's propionate. And it's 2 words because it's common, propionate. And voila! There you go. Okay? So, that's how you do these. So again, you still have to use your alcohol chart for the common names. It is going to crop up in your homework assignment, in your practice problems. But the process, if you don't get it the first time, watch this again, because I think you'll find that there is a distinct method that makes all this make sense. Okay? So, practice problems. Oh yeah, that's a separate attachment. That'll be in your assignments. Have fun.